Hello everyone, in this lecture we're going to discuss about the first law of thermodynamics. So basically first law of thermodynamics is introduced by J.R. Mayer in 1841 and it was formulated by Helmholtz in 1847. Basically first law of thermodynamics is related to law of conversion of energy. That probably states that when the energy becomes conserved, so that state the first law of thermodynamics. First law of thermodynamics also states that the system cannot be created nor be destroyed. However, energy changes form from one type to another. Just suppose that this is a coal energy. This is a coal. And now we are using this coal to create the electricity. Now here coal is not changing or not creating the energy, but coal has internal energy and that energy is changing its form from the coal to the heat or electricity. So this is called the regulation of the energy. According to first law of thermodynamics, in a physical or chemical process, the net energy of a system and its surrounding must stay constant. Now, first understand the concept of the system and the surrounding. Just suppose that I do have a ball inside this beaker. Now, here this ball is the system and each and everything surrounding this ball is called surrounding. Just suppose that this ball is in the beaker. Now if I'm taking ball as a system, so beaker is also the surrounding, this cap is also the surrounding. So this is how the surrounding and the system can be differentiated. Basically, if we talk about the mathematical representation of the system and the surrounding and the first law of thermodynamics, so it states that E, change in E, that probably means change in internal energy within the system is equal to Q, the heat, plus W, the work done. Now just suppose that this is a beaker. Now this is a cap or pistol. Now just suppose that there are gas particles inside this beaker. Now at initial I am giving this beaker the heat energy. Now this is an external energy that I am giving. Now probably the gas particle will start colliding and this pistol from this side will move up to this. Now these gas particles will be randomly moving. Now this change in the distance of the pistol is known as work done by the pistol. But here this heat is by the system. The work done is within the system or in the system. And this heat energy is by the system. So if we talk about Q, heat, so Q is equal to del E minus W. Heat energy can be determined by simply subtracting the work done. That probably means that the distance by the internal energy, the actual energy minus the work done is probably the value of the heat. Now here are some conditions. When in a condition the Q is positive, or if we talk about the Q, so if the Q is positive in the equation, so that states that the process is basically in the system. And when the Q is negative, so basically that states the process is by the system. Or we can also state that heat absorbed by the system, so we denote it by positive. If heat is absorbed by the surroundings, so we denote it by negative sign. Now whenever the internal energy increases, internal energy, that probably means this internal energy movement of the particle increases. So basically the work done is positive. When internal energy decreases for some reasons, so the work done is negative. If the work done is on the system, that probably means that I am giving this the heat. Now this internal energy exudes, excited, and they start colliding, and work done is done by the internal particles. But there is a condition when the thing is by the system, that probably means that I am giving some kind of pistol, I am increasing the length of the pistol. Now this is by the system. So in this case, the work done will be negative. I hope that first law of thermodynamics is clear to you all, and thank you so much for watching this video.